this video, we're going to be talking about how to find the derivative of secant x. Okay, so we don't have any traditional way per se that we know of yet in order to take the derivative of this straight away. So let's just take a problem that we don't know how to do and change it into something that we do know. So using a reciprocal identity from the other video, we can say that we remember that secant x equals 1 over cosine x. Okay, so now this is something divided by something that we can take the quotient rule of. So if you recall from my other video, d of something in the form of u over v dx equals v minus du dx minus u dv dx over v squared. Well, okay, so in this case we're using some, let's call this y, so we have y equals f of x equals some u over v equals our 1 over cosine x, secant x we care about. So now we're just going to say that our u of x equals 1 and our v of x equals cosine x in order to make this substitution possible, in order to plug the functions into the formula here and see what we come up with. So now we can say that d secant x dx equals d 1 over cosine x, is these two are equivalent, dx. So knowing that, we can say that d secant x dx equals, well, just plug things into the formula here. So this is going to equal our v of x is cosine of x times, well, what's the next piece? That's going to be our d dx of, in this case, is 1 minus our u of x piece, which is just 1, times our d dx of, looks like, cosine of x divided by cosine x quantity squared. So now let's just evaluate this and clean it up. So we have cosine x times, well, what's d dx of 1 going to be? Well, if you recall the power rule, then anytime we have something in the form of y equals k x to the n plus c, then we're going to have y prime equals n k x to the n minus 1. So that means that d dx of 1 is going to equal d dx of 1 times x to the 0, because remember these are equivalent. So now using our formula here for the power rule, this is going to equal, our n is 1, so 0 times k is 1 times x to the 0 minus 1. And notice how 0 times all that is just going to give us 0. And anytime you have a constant, the derivative is going to be 0, by the way, so that's something important to keep in mind. So this is going to be cosine of x times 0, and that piece just goes away, minus 1 times, if you recall, the derivative of cosine x just equals the negative sign of x. If you don't have that memorized, you should try and make an effort to do that. So the derivative of cosine x is negative sine x all divided by cosine of x squared, and this piece goes away and we're left with minus or plus, so this is going to equal sine of x over cosine x squared. But notice how we can split this apart. So we're going to have this equals 1 over cosine x times sine x divided by cosine x. But notice here as well that if we have sine x over cosine x, then we can cleverly split this apart by saying the opposite over hypotenuse divided by adjacent over hypotenuse, and the hypotenuse piece goes away. So we're going to have this is equal to opposite over adjacent, or tangent x, as we know, tangent to v. And remember that 1 over cosine x was our original secant x, so this is just going to equal secant x times tangent x. So d secant x dx equals secant x tan x. So this just means that the derivative of secant x with respect to x as the variable equals secant x times tangent of x. So yeah, this is how you would figure out the derivative of secant, and you're probably going to use this one on your tests and homework a lot, so make sure to keep this one in mind too. So okay, hopefully you found that helpful, and come back for the next one where Joe shows you how.